Good morning. Hello, everyone. Thanks for coming this early on Friday, and welcome to this first edition of Ethereum Privacy Stack. Yes, Privacy Stack, what does it mean? Privacy is not one killer application or one solution that will actually enable us to have a better online experience and freedom in democracy, in civil society, but it's rather a collection of tools, applications, protocols, and behaviors. Because as the historian Timothy Snyder says, privacy is an act, and freedom is an act of practice. And this is why privacy goes from Ethereum to Tor, from Web3 to Web2, from hardware to software. And it's all a matter of us deciding what kind of digital footprint and online experience we want. To give some insights and inspiration to young people coming to the space, but also to the most navigated and experienced one, we asked to several change makers in the space what is their privacy stack. So what are the solutions that they find more ready to use, more useful? You can find these actually online on stacks.web3privacy.info, or rather here outside there is a huge banner, and you can navigate this and find whoever is your hero and see what is the stack that they actually use. We did the same for the whole ecosystem in Web3, because we really think that we should actually team up and stop competing, dividing the ecosystem and dividing the different communities into small, gated, or let's say separated bubbles, because at the end we are here for the same goal. And as privacy is a stack and is a collection of solutions, we should actually team up and make this composable as much as we can. Same for Ethereum privacy ecosystem. With PSC, we basically mapped the whole ecosystem. You will have more details about this at 1 p.m. We will have a session dedicated to this one. And last but not least, let's make privacy fun. Because if you Google privacy, you have these like gloom and doom, hackers, code, matrix, whatever it is. But privacy should be normal. Privacy is embedded in every constitution of the world. And it's a fundamental human right. And we don't have, at the moment, like enough strong law that preserve privacy in the digital space, but we have a lot of different advocates and amazing human beings that are actually advancing this cause, whether with policymaking, with marketing, with design, with their words. Maybe they are writers, they are singers. So the concept here is that you can be useful for privacy, not only if you are a cypherpunk. Because in the last 2 years, I'm very glad that this is happening. The cypherpunk narrative is coming back into the, let's say, main discussions, which is great, but people feel excluded because if I don't code, I feel I cannot advocate for privacy, or I'm not a cypherpunk, so I cannot do, the real work, which is not true. And this is why we are actually pushing forward this new narrative, new kind of cypherpunks, like cypherfunk, cypherpop, cypher whatever you want, or not even cypher. We can all be new cypherpunk, basically meaning that going away from, again, this like wearing hoodies and justify code hard or use Linux can do something useful and meaningful. And let's try to actually gather around the same values that unites us all and bring all of you here in this room this morning. And let's try to act rather than react, because there is like all this criticism, especially in social, saying you're not private enough, Signal might be controlled by the government, this is not good enough. And we are actually spending time and energy criticizing each other rather than confronting the same enemies or the same challenges that we're all facing. So let's try to act rather than react. And let's try to support each other, collaborating, giving feedbacks. And last but not least, let's try to have fun, because activism can be fun. Building privacy can be fun, can be colorful. Look at, for example, Fileverse, an amazing experience of how you can use anime and manga to just, make privacy fun, make a service more friendly. Yes.
Well, thanks. This has been a great introduction. I want to thank you all for being here. I'm Brecky. I'm from the Privacy Stewards of Ethereum team. Yeah, I mean, it has been a long week. We're almost finishing. I know there has been a bunch of parties, but you're still here. And I think that's very important. That displays that you're interested in this. So you acknowledge that privacy is a mission. Privacy is something that we must defend. And it's something that we all can help to create this. And we all perceive that this is very important for us. Sin privacidad no hay libertad. Without privacy, there's no liberty, no freedom. So thank you all for being here. Thank you, PG. So we're going to begin with the first round of lightning talks. The first one is starting now?
Yes.
Cool. All right. So Fabrizio and Stefano, they're bringing post-quantum cryptography back to Ethereum. So we acknowledge post-quantum, the dangers of post-quantum computing, and we think this is a very important mission to take care of. So, yeah.
Welcome on stage.
Welcome to stage.
Enjoy your day.
And Stefano.
All right. Just check that this works. Nope. Ah. Well, it doesn't go back. Fantastic. Hey, this is good enough. All right. Good morning, everybody, and welcome to this Privacy Summit ACT not react, is kind of our approach to quantum defense and the opportunities of quantum in crypto today. We are never local. We are a small company focused on the intersection between quantum and crypto. We are focused on both the defense side and the applications or attack side of quantum. We want to make sure that Ethereum and crypto more generally is prepared for what's coming, that we can defend against a quantum threat, but also that we can make the most out of what quantum technology can offer for crypto, the new opportunities. So this is going to be a two-part lightning talk, so really lightning. The first part is going to be me talking about how we plan to defend Ethereum and what we need to do to make sure that the chain keeps operating. And the second part is going to be Fabrizio, who is going to talk about applications of quantum to get new cryptography. Here is really the key message. Quantum is coming. It's not up for debate. It is a fact. Quantum is new technology, of course, but there are clear roadmaps from large manufacturers. There is a lot of investment on these roadmaps, and you just need to check the publications, peer-reviewed publications that all of these companies put out. They are on track. And the roadmaps say that around the mid-2030s, their capabilities will be such that elliptic curve cryptography is going to be broken. Now, that's the expectation, but there is a non-zero possibility that elliptic curve cryptography could be threatened by the late 2020s, so 2028, 2029. It's not the most likely scenario, but it is possible with a fairly good probability. And so we need to start preparing for this. We need to start preparing now. This is ongoing work in the Ethereum ecosystem. Most of the work, though, is focused on changing the core cryptography layer. So introducing post-quantum signatures in a way that maintains sufficient performance. That requires significant time and significant coordination for a change, definitely a fork and consensus from all the validators. This is okay if Q-Day happens after. But what if it comes slightly earlier? What if it catches us unprepared? What if we're caught by surprise? We need to have some mechanism that allows for an emergency fallback, a graceful emergency fallback, a way where the chain can keep operating if quantum technology advances quicker than we expect today. This is something that has gone wrong. Can we fix this? Hello? All right, well, I will just continue talking. Yes, thank you. Luckily, we already have a post-quantum piece of post-quantum cryptography, a quantum-resistant step in the derivation of our private keys. This is the BIP32 hierarchical key derivation mechanism. Part of the derivation is a quantum-resistant hash. And so technically, we already have information that can be used to demonstrate ownership of an address in a quantum-resistant way. And this can be done today. It can be done with current zero-knowledge technology. ZK Starks are themselves quantum-resistant. And so we can safeguard at least part of the authentication process in Ethereum and in other chains by just lifting the signatures from the current quantum weak ones to the quantum resistant ones with a proof of derivation from a seed phrase. And here is where Ethereum is uniquely positioned to resist a quantum threat, resist an unexpected Q-Day. We have account abstraction. Ethereum is the most sophisticated of the smart chains. We have a lot of delegation already implemented and supported, and we can deploy Stark-powered smart accounts even today using delegation and permits to allow the chain to recover and keep operating in a quantum emergency. So it's a matter of getting things done. It's a matter of acting now. And we can safeguard users, even users who don't migrate in time, from an unexpected quantum emergency. So this is the defense side. Great, we've done it. Imagine it's 2030. Quantum computers didn't come, or maybe they did come, but we fixed it. Ethereum is safe. Quantum is here. Quantum technology is readily available. What can we do now? What are the positive uses of quantum technology in crypto? Fabrizio, to you.
Thank you. Hello, everyone. So I'm Fab. OK, so yes, the year is 2030. We saved Ethereum. We are all happy. What can we do? Well, I like to make this analogy that quantum really is like a big, scary dog. It can tear you to pieces, but it can also be a very nice puppy, very valuable, and brings a lot of good things in our lives. So how do we harness the puppy side of quantum? What can we do, assuming that we have quantum, to improve the overall situation? So the main point about quantum is that quantum does not behave like data. It behaves like a resource. What it means is the following. If I tell you something, like I'm doing now, with this talk, you can take this information and tell it to everyone you know. You can copy this information arbitrarily. If you are, math-versed in a logical system, this means that you have weakening, so you can use the same information again and again and again. On the other hand, if I give you an apple, you cannot really copy an apple. You can give it to someone else, maybe you can split it, but you cannot make a copy of it. And qubits and other quantum resources behave exactly like apples, not like data. So this thing allows us to basically do a lot of incredible cryptographic stuff that is provably impossible to achieve classically. One of these applications is, for instance, device-independent security, which basically means cryptographic protocols that stay secure even if the hardware they run on is compromised. Shout out to Stefano and Nicola that are heavily working on this particular field, which uses a lot of complicated maths called contextuality. Another very important application is that quantum can make protocols one-shot. You probably heard about one-shot signatures. This is a topic that we started investigating a couple years ago, together also with Justin Drake, and the idea is that we're talking about signatures that can be used only once. You can delegate someone to sign whatever message they want, but they can do it only once. And this is probably impossible to do classically, because once you give your signing key to someone, they can use it as much as they want. Similarly, we can make multi-party computation one shot. And shout out to Lev, a colleague of us that is working very heavily exactly on this kind of thing. Another very interesting solution is that we can basically realize one-time memories and one-time programs, which, as the name says, are memories and programs that can be used only once. And you do not need TEs to do this stuff with quantum. If you assume the NISQ regime, we're not going deep into that, you can basically do it out of the box. And again, this means, in particular, that we can do quantum money, which is the holy grail of crypto, basically. Quantum money is so simple, which is sometimes difficult to grasp. You have to imagine something that behaves exactly like cash. There is no consensus protocol. It's peer-to-peer. It's private, is inherently decentralized. It works exactly like cash. And again, this is possible because, since quantum behaves like a resource, the idea is that if we have a way to knit value into quantum resources, then we can only exchange them without cloning them, without being able to copy them. So this quantum money is basically completely unclonable by default. And again, the funny thing is that all these things are guaranteed by physics. They are not guaranteed by computational assumptions. If you believe that our current description of the physical world is more or less correct, then that's it. Okay, super cool, but how far away? Well, this is the interesting thing. Unironically, quantum cryptography is the lowest hanging fruit in quantum. We do not need any, exponential speed up argument. We don't need a lot of qubits like we do for Shor and all these other quantum algorithms. So this is unironically the first thing that we can get. And it can be done with near-term quantum tech, basically. And indeed, we are already working on it. This is a picture from our lab where we have all these weird single photon emitter and single photon detector equipment exactly to experiment with these things. So the take-home message for this talk is that I would like to give you a more hopeful version of what quantum is. I really don't like doomerism, and I think that quantum can do a lot for us. So embrace a most hopeful version of what quantum is. That's it. We are around all day and afterwards, so if you want to know more about quantum money, quantum, post-quantum cryptography, etc., hit us up. Thank you.
Thank you, Fabrizio and Stefano.
Thank you.
Thank you so much. All right. So who here loves privacy infrastructure? Good. Many hands. I see. Cool. All right. So we all love our privacy infrastructure. We all love our privacy applications. But yeah, we want to keep using them. So for this, so that no centralized, let's say, things prevents us from using them, sometimes we need to add compliance tools. So our next talk is about Predicate, a compliance tool that is being used so far with Aztec, for instance. And so, yeah, please welcome. Let's go for Predicate.
I need my laptop here, or?
No, your slides.
Oh, perfect. Okay. Perfect. Thank you. Hey, everyone. How are you guys doing? All right. So first up, I think we have to define and think about the world as it is today and where it goes, right? So I'm sure many of you guys share this view that blockchains will become the global financial settlement system. This was me pulling the numbers from last night. I don't know how it's changed. I haven't looked at the markets this morning, but hopefully it's same, if not a little bit higher. But the point is generally that you actually see a significant amount of growth in digital assets over the last, even over the last year. You're seeing record amounts of, from a market cap standpoint, stablecoins really does seem to be the real fundamental use case for blockchains, right? This is something we've always talked about, but you're actually seeing that adoption, not only in crypto world, but you're seeing that happen through fintechs and financial institutions as well. And then, of course, you have real-world assets and DeFi itself. So all this means that we are really going into a world where blockchains do become a global financial settlement system. And privacy is critical to that, right? We cannot have a world in which all of our financial activity as a user is fully revealed. But same for any organization, they also cannot have everything be disclosed publicly for a number of reasons, right? From a business execution standpoint, for payroll, they can't have all of their employees see how much everyone is making. A business can't show how much are they paying their different vendors publicly, both to their other vendors as well as their competitors. You could pretty much backtrack their entire financial position through things like that. So in this case now, we say privacy is critical, right? But what that also means is you're also engaging and interacting across regulated markets. Users are coming in from regulated markets, and businesses, of course, exist and operate in regulated markets. So the question then is how do you incorporate compliance into that to be able to scale into the global economy? And really the question is why compliance, right? It's because developers and organizations that operate in regulated markets have to think about their business requirements, such as, they don't want to reveal everything, but they have to ensure that they're not, sending money to someone who's malicious or receiving money from a malicious actor. There's, of course, regulations and security. So to make this even a little bit more tangible, what I think about here is, you and I will all go buy a pair of shoes. But when we go buy a pair of shoes, we don't go to a back alley and say, oh, I'm going to go and buy a pair of shoes from something that was clearly stolen, right? We actually don't want to do that. We usually go to a store and say, let me buy a pair of shoes. So again, this is where compliance does matter. And so this is really what we see, right? So this is what the purpose of Predicate is we build policy infrastructure for privacy solutions. And core to this is that we believe that Ethereum should be credibly neutral. None of this should be enforced at the Ethereum core protocol level. But rather, you are building financial solutions that sit on top, privacy solutions that sit on top. And so in that case, you need policy infrastructure to be able to power that. And so really then, it's that policies control how transactions flow in financial systems. That's historically how it's always worked, and that's really what the view that we take as well. All right, so how does this work? Quite simple. It's not too complex, actually. So you have a financial application or a privacy application, in this case. You have a predicate API. So in this case, they request the predicate API to issue a signature, saying, hey, this transaction that's about to go through, let's say someone wants to enter into a privacy system, is it compliant or not? And if it is, predicate issues a signature, an attestation in sub-second latency. Basically, we have an off-chain compute system that validates the transaction, says, does this adhere to the requirements? If so, yes, we issue a signature. Then when the user is submitting the transaction, that signature is embedded in the transaction object. The user is never going to really realize this. We should not be fundamentally changing the user experience. It should be very, very consistent with what they already have. So they go through, they don't realize it, but they have a signature embedded in the transaction object through predicate. So they then hit submit. The transaction only goes through the smart contract if there is a signature from predicate. If there isn't, the transaction can't go through. So what this means is we are actually creating mechanisms to have compliance enforcement at a smart contract level for various applications, right? So a transaction can only go through if it has a signature from predicate. We attest to whether something is compliant or not, and it is enforced at a smart contract level. And then lastly, the signatures are validated on-chain through the predicate contracts. So I'm going to have one slightly more abstract slide, and then I'm going to go into like a few tangible examples of this. So what this means is when you think about policies in this architecture is you're allowed to do smart contract level enforcement in which transactions only execute per defined settings. Fully observable, right? So you can see in real time if they're going through, if they're not going through, why they're going through, why they're not. The other part is it's one integration. So you're going to need to incorporate, when we really get into the incredibly boring parts of compliance for everyone here, you have to think about a number of different data points, on-chain and off-chain. This is zero knowledge proofs, this is off-chain data, this is proprietary data, any of those things. It's really how do we have a unified mechanism to be able to do all of that. And then lastly, it should be programmable, right? You incorporate this once, you should not have to update your smart contracts every time. If something changes for your business or regulation changes, you should be able to update that. It should be programmable without having to make any dramatic changes to your infrastructure. All right, so let's make this now even more concrete. So IntMax is a privacy L2 on Ethereum. They need to ensure that malicious actors can't enter into their privacy system. And so the way this works is it's in their deposit contract. So anyone who's going to go and deposit, that predicate is essentially used to verify that those funds are not coming from a major exploit or coming in from a major instance of terrorist financing or human trafficking. So when a person's about to deposit, this is verified by predicate. And here we use a multitude of different data inputs for that. So for example, TRM, which is a blockchain analytics provider. There are various custom other data sources that we use. And these are, of course, all defined by IntMax. A crucial part here, right, is that you have to have a number of automated redundancies because you can say, hey, look, TRM is right there. Isn't that, if there's a Cloudflare issue or an AWS outage, what happens? Are you basically stopping every transaction into IntMax? And that's where this is really important in the way that this is designed, is it should have auto capabilities to incorporate a number of other data pieces. If TRM goes down, if there's a major outage in the world, you should have various points of input. And again, this is where you incorporate custom blacklists as well that use much more on-chain infrastructure. So that's IntMax. Now I'm going to talk about one, Aleo. Obviously not an Ethereum blockchain, but I think what they do is very interesting, and their approach is very fascinating. So Aleo is a layer 1 blockchain, passed a governance proposal. Their ecosystem passed a governance proposal and said, hey, we are a privacy blockchain. And so we need to define and enforce some best practices for our bridges. Not for the blockchain as a whole, but we as an ecosystem believe that bridges should be taking some certain best practices. They didn't say exactly what you have to do. They said, here are some things, take some set of them and do that. And so this included basically time delays, 24 to 72 hours before bridging, a limit in the amount that can be bridged in any given day or any given transaction, screening against high-risk addresses, right, such as sanctions and addresses involved in major exploits. They said if you want, you could do KYC, really up to you. But the main thing was they said, hey, we have to have at least some shared view that we need some best practices for our ecosystem. And I think it's a really interesting approach, right? They as an ecosystem passed a governance proposal. It's a much more decentralized mechanism of doing this. And so all of those bridges then use predicate to be able to enforce different requirements such as these. Perhaps not all of them, but a subset of them. Then the last one is when we go to some of the more institutional use cases. And so then we start thinking about identity, right? Identity is tricky because we have traditional KYC, KYB systems, but then we also have really where I think the world should be going, which is zero-knowledge identity, right? Zero-knowledge identity ensures that we as people have custody and control over our own personal data without it being out in the world. The challenge, of course, is not every institution today is comfortable with that. So we have to think about how we accelerate that forward. How can we have zero-knowledge solutions sit alongside traditional systems, abstract that away that over time we continue to position zero-knowledge identity to be able to replace traditional identity solutions. And that's really how we've been approaching this, is that you can actually aggregate across multiple solutions simultaneously for a more unified verification. I'll give an example of this shortly. You have a front-end experience that allows a user to go through whatever process they have, whether that's getting a ZK identity solution or going through traditional KYC, and then immediately being routed back to what they need to do. So what I'm emphasizing here is the need for seamless UX experience, right? Like it has to be seamless. That is a big break-off point for most financial systems is any changes in the user experience halts activity. And you can see that drop off. You can say, there's 1,000 people coming in. Oh, they got blocked here. You see a 20% drop off. You see a 30% drop off. We can't allow that to happen. We have to ensure the best UX possible. And then the last one, of course, is enforcing these requirements at a smart contract level such that if something isn't met, it's rejected. So I'm sure many of you saw the Aztec, the Aztec token sale. So this is exactly what we do there. So if you go to Aztec, there's two flows. You can choose to use ZK Passport, which has a fully zero-knowledge identity solution. But if you're someone in a market who doesn't have an NFC chip in their passport or don't have a passport, or your passport's NFC chip isn't working, or perhaps you're not able to download ZK Passport, we also have a more traditional KYC approach. And then, of course, for KYB, which is for businesses who need to participate, zero-knowledge identities doesn't currently offer a solution there. So really what we've done is we've given users choice on which direction they want to go through. All of this is unified, right? So from a user standpoint, they can choose what they want, and these are still enforced by predicate. In addition to that, we have some additional components that are integrated on the back end. But again, it's about a unified experience in which people don't realize or people have the ability to choose what they want to do. And from a technical standpoint, it's all the same unified experience. And really, this is where we see the world, is that organizations need to think about a holistic set of rules, whatever that is, right? Whether that is they're a financial institution in Europe that has to think about MiCA, whether they're a payment system in Latin America that has to think about payments across different countries in the region. There's a holistic set of business, legal, and regulatory requirements that they all have to consider. And so that is a multitude of not just AML, not just KYC, but things such as rate limits, security, geolocation. All these really matter. And this is crucial when we think about the scaling of Ethereum. And then the last part, of course, is can't leave a presentation without talking about AI. When we think about an agentic economy, when we think about transactions across AI agents, you will need to ensure that your AI agent behaves in the manner that you want it to behave, right? How do you ensure that it does the things you want it to do? And so last I wanted to end with this is we're finalizing a paper with Inco on compliant privacy. And so really the purpose of the paper is there are so many different approaches to compliance, and it really is a tricky thing to figure out, right? Like, how should I be building privacy and how should I be building compliance? And there's a lot of different ways to do it. And so the purpose of the paper is we present a framework for different styles, and it includes a number of different case studies for many organizations that do it, not just the ones I mentioned, but I think other great examples are privacy pools by Oxbow and Amin Soleimani. Railgun also has an excellent approach to this. So there's many, many different styles, layers, and forms to it. And there's, of course, many different types of privacy use cases, many different types of privacy, fully anonymous, confidential, public, of course, or pseudo-anonymous. And so really, the purpose of this paper is how can we make that a little bit easier to understand for organizations and developers. And so with that, I'll be around for the rest of the morning and early afternoon. If you're interested in learning more about the paper, anything we do, happy to talk further. So with that, thank you very much.
Thank you, Nikhil. So we're all into private transfers, but what if I will tell you that there is a way to do these private transfers without interacting with any L2 or any smart contract? So our next talk is going to be about Worm, and they will explain how we can do this on Ethereum. So please, welcome Shahryar.
So is this... Okay. Hello everyone, I'm Shahryar. I'm a co-founder of Zero Savvy. It's a non-profit research organization in UK, and also I'm a research associate in Alan Turing Institute. I'm super excited to talk about this private proof of burn, and like how using that you don't have to scream that you are going private on chain. It's a backbone of many new interesting protocols, privacy protocols, and yeah, let's head to the problem. So the idea is that privacy probably will never be as equal as invisibility. We want to make it as close to invisibility as possible. And no matter what type of privacy protocol that you are using, at some point you need to interact on chain in a different way than just a normal transaction. Either you have to interact with a contract, or there are some proofs involved. Anyway, you will trigger some sort of signal that might leak some information about you. And this can be very serious when, for example, you're a big firm, you want to go into the big auctions, or you're a big company, you want to handle your salaries of your employees privately. These things can be serious and can be captured by your business enemies or anything. So it's important, like how can we make it as invisible as possible, just to look like a normal transaction. Okay, so the proof of burn, it's actually a very old concept. It existed from the early years in Bitcoin, and there were even very interesting blockchains built on it. It was involved in the consensus of the blockchain and everything. But it was academically formalized back in 2020. Definitely check that paper if you're a cryptographer, and yeah, that has very interesting properties proven about this. But things got very interesting, especially after August 2023, when some people proposed EIP 7503 and introduced the concept of zero-knowledge wormholes. And we'll see what is it about. So okay, the burning, what we know, what we are very familiar with is that you just send your assets into address 000. Why we all know that this is an burning mechanism is that, of course, we are aware that it is super hard to find the secret key that can withdraw from this address. Everybody knows that. And I'm not going into the detail like why it's secure, but yeah, it is like this. But you know, it is proven that it's not only about like having an obvious address. You can use any sort of secure commitment, like we call it, like, think about it as just a random, secure random function that it's just other than the standard address derivation method in Ethereum. So this way, if you send the transfer to that type of address, you will know that it's impossible to withdraw from this address. And this can be done in any ways. Like you can say that, for example, yeah, I'm Shahryar, my vote is, for example, 2. And then you hash this string. And this is, of course, will result in an address that you can burn into. You know that your funds are gone. And like, OK, why would you do that? And this is where this EIP comes. And this is the very interesting part, is that you can prove that you have burned this token. And then you will keep this address private. So this way, this is the whole concept of private proof of burn. And very simplified version of it, like this is not perfectly secure, but like this is just simplified version of it, just saying that you prove that, oh, you know, I know a burn address that falls into this type of category of the address, and this address has positive balance in the latest state root of the blockchain. So basically, this is the whole concept of this, how this ZK works. And the very good thing about this type of proof is that it is very composable friendly, like in terms of the cryptography. It is not proven in UC. If you're into these things, I'm really interested in to prove this in UC, so contact me if you're into those things. But you can combine this proof with interesting other proofs, like proof of innocence. So you can prove that, oh, my funds are not part of the bad acting, or I'm not a hacker, and then you can burn your vote, and then you can participate, for example, in voting. Or you can participate in a privacy pool that it's authentic. It is like there's no way that other bad actors could satisfy those kind of constraints. And even if you want to show that, you can actually show that, oh, my transactions are not burned transactions, or you can actually reveal it securely only to one person that how you have burned it. So if we revisit the problem, is that with this kind of technique, you don't need to interact directly with a contract or a privacy protocol. You can burn your address, you know, your assets, and this is just a normal-looking transfer with to just a normal-looking address. There's no, everything looks random, and then the very good thing about this kind of protocol is your anonymity set. This is like the biggest anonymity set that you can achieve at the moment, and this is like every address on chain that hasn't have any outgoing transaction will be part of your anonymity set. This is a very big anonymity set, and this is the cool thing about this. So there are some current active research going on in this, using this kind of protocol. And of course, the very first one, the obvious one, is the EIP itself. So the EIP was like saying that, okay, you know, you burn your ETH, you prove it, and then maybe you get something back.